In the previous video, we saw how to state parameters in an object to allow it to receive data from another object and perform the corresponding actions according to this data. To this end, we used the parm rules and variables. The examples we saw involved input parameters, that is to say, parameters only received by the object. In this way, if object B has a parm rule stated with 3 variables, to invoke object B, any object will have to send it 3 values that, as we've seen, may be saved in attributes, be an expression, as in the case of a fixed value, or be saved in variables. Now we will see what happens when object B must return a value to the caller object when it ends running. In the flight transaction, we had a formula that calculated the price of a flight according to the discount percentage offered by the airline and the percentage indicated for the flight itself. It selected the biggest discount and applied it. Suppose that we're creating a transaction to record the invoices issued to customers when they purchase flight tickets. Also, let's suppose that the discount is a more complex calculation that implies not only the flight, but also some condition related to the customer who is purchasing a flight ticket. For example, the number of tickets he has purchased in the past, if he is a recurring customer, and if a destination is offered at a discount. The discount percentage is determined according to these more complex conditions. For cases such as this, we may need to implement a procedure that makes these calculations and returns the resulting value to the caller. For example, we could call this procedure getDiscount. The procedure will have to receive the customer and flight as input parameters, and it will return the resulting discount. The first question is how this result is received by the object that needs the procedure result. It has to be considered as a function that is called in order to perform an action with the result returned. One possibility is to assign the result to an attribute. For example, we could define the flight discount attribute in the invoice transaction structure as a formula that is calculated by invoking getDiscount. In this way, the formula will be evaluated in every object where the invoice flight discount attribute is mentioned. The getDiscount procedure will be invoked and executed, and when it ends running, the returned result will be shown as the formula attribute value. If we don't want to set this attribute as a formula, but rather we want it to be an attribute stored in the corresponding table, and have it stored with the procedure result only when the transaction is executed, we type the following. In addition, the result of the procedure's execution could be assigned to a variable. Also, it may not be assigned, but used in an expression instead. For example, to condition the triggering of a rule, or of instructions in a procedure or an event. We will not be talking about how to implement the getDiscount procedure, because it's not relevant for what we're studying now. However, we must see how the parm rule is stated in the called object when the call syntax assumes that the object returns a value, as in the examples that we've just mentioned. In the rules section of the getDiscount procedure, we must state the parm rule with the number of parameters described in the call, plus 1 at the end. That will have to be a variable whose value is loaded in the object code, and in our case, in the procedure source. The value taken by the variable when the code ends running will be the value returned to the object that called it. Lastly, let's take a look at the case where a parameter of the parm rule is an attribute instead of a variable. What's the difference between using a variable or an attribute in the parm rule of the invoked object? If the value is received in a variable, it can be freely used in the programming. It can be used as a filtering condition for filters such as equality, higher than or equal to, and so on. Also, it can be used for an arithmetic operation, or for whatever is necessary. It's a space in memory with a name that we use within the object through explicit instructions to do what we want. For each parameter declared in the parm rule, we can define whether the parameter is used to receive a value, to return a value, or both. This is done by means of in, out, and in-out operators, respectively. The in operator indicates that the parameter is an input parameter. In other words, the parameter comes with a value, and that value cannot be changed. Parameters without operator are output parameters. They don't bring any values, and after the called object is executed, the output parameter will contain the resulting value that will be returned to the calling object. Lastly, an operator called inout makes the parameter input and output at the same time. With this operator, the parameter comes with a value and can be changed during the execution of the object. When finished, the parameter will contain the value that's returned to the object that called it. If none of these operators is declared in the parm rule, GeneXus will assign the inout operator to all parameters, even if this is not displayed. If, on the other hand, the value is received in an attribute, this is fixed, determined, and implicit. We receive values in an attribute when we access the database from inside the object. In particular, a table in whose extended table this attribute is stored. So, when a value is received in that attribute through a parameter, an equality filter will be applied. Only the records that have that value for the attribute will be considered. Let's see this with an example. We make a copy of the attractions list procedure with the attractions report name. Remember that the procedure on which it's based uses a variable as a parameter, country ID. It used it to filter the attractions in the attraction table by country. As we can see, it is implementing an equality filter. It will list only those attractions whose country ID matches the value of the country ID variable received in a parameter. We could have implemented exactly the same without explicitly indicating that filter. How? By receiving the value directly in the country ID attribute. When we receive the value in an attribute in the parm rule, GeneXus uses an equality filter. That is to say, only those records that have the same country identifier are accessed. If we look at this object's navigation list, we can see that the filter is applied even if the where clause is not written. It's interesting to note that since the for each command is being run through ordered by country name, the entire table has to be run through to filter by the country ID values corresponding to the parameter. On the other hand, if we order it by the attribute used to filter, we see in the navigation list that the entire table is no longer run through. We run it, and we upload everything to GeneXus server. If we received more than one value using attributes to receive them, only the records that have the same value as each attribute received would be accessed. Also, we cannot change these attribute values. If our objective is not to receive values to apply an equality filter, the solution will be to receive values in variables instead of using attributes. In addition, they can be freely used in the programming, for example, to assign other values to them if necessary. Communications between objects is essential for any GeneXus application because it enables an object to start running another object and send or receive information to and from it. There are other ways of communication between objects in which there is no passing of data by parameters. One example of this occurs when information persists in memory through web session variables, or when global events are used. These cases will not be seen in this video, but it's important to note that there are several and diverse forms of communication between objects.